So, good morning, everyone. Welcome to Salt Analysis Lecture 4. And this will be the final lecture of Salt Analysis. Yes, that is a surprise because I told someone that I will be finishing on January 14th, but I decided to, I sat for 10 hours today and I prepared this entire PPT. So, one thing I want to apologize for in advance is that the basic radicals part has a lot more memorization. Like you have to memorize a lot more stuff, and unlike anions, it was very hard to come up with tricks of basic radicals, and hence it took me so long to come up with this lecture. Like usually I upload at 5:30 p.m., but it took me 2 hours extra just because I spent a lot of time thinking about proper tricks. And another thing is that you will feel that the tricks are very scattered. Like there are a lot of tricks in this video, and tricks are basically their mnemonics. So you will find it difficult to remember all of them, but I can promise you that if you gain a proper control over the tricks that I will share in this video, you will not forget any of these tests. And overall, if you are not going to use any tricks in the first place, then remembering all of this without a trick would be cumbersome. So please bear with me and I will try to make this chapter easy for you. Now, some of the you can skip my yapping, I'll provide a timestamp. Basically, some of the things in this lecture are not mentioned in your syllabus, but they have asked questions from it. So, I have analyzed the previous year questions and added those things in this lecture. So, first, let's start talking about how do we test for basic radicals. What is the procedure? So first of all, the very first thing that we have to do is we have to do a physical examination. The sample of the salt will be in front of you and you have to look at its color, and you have to basically heat it in dry state and see what color it changes to. So that is a physical examination. After that is done, we are going to perform a dry test. What is a dry test? A dry test is a test in which we are not going to add any kind of solvent to the salt. We are only going to use the salt in its dry form, like solid form, non-aqueous form, and we are going to perform tests on it. The tests being the flame test and the borax bead test. And the third thing we are going to do is that we are going to test for the ammonium ion. Like all the other cations, they are metals, but ammonia is the only non-metal cation we have to study, and we are going to test it with using K2HgI4, Nessler's reagent. We are going to study. If the test passes, then we can confirm presence of the ammonium ion, and if it doesn't, we are going to prepare a solution called the original solution. Now, what is the original solution? I'll finish it on this slide only. Basically, an original solution is a source of the salt. Like you have to dissolve the salt in a solvent. Now, some salts are very stubborn and they will not dissolve in water. So we have to follow this order to dissolve them. So what is the order? First of all, if you have your soil sample, after testing for the ammonium ion and it fails, so you prepare the original solution, you decide to prepare. So what you have to do is you have to add the salt in water. This is water. Now, if the salt is soluble, then well and good. This is the original solution and you can use it for testing. But if it is not soluble in water, you then have to try mixing it in dilute HCl. Like if not in water, then in dilute HCl. If it does not dissolve in dilute HCl, you have to try and heat the solution. And if it does not dissolve in dilute HCl at all, you are going to try with concentrated HCl. And if concentrated HCl does not work, you will try with nitric acid. And finally, if nitric acid does not work, you are going to use aqua regia. Now remember in class 10th we studied what aqua regia is. Aqua regia is basically a 3:1 mixture of concentrated hydrochloric acid with concentrated nitric acid. And if the salt fails to dissolve in aqua regia, we will call the salt insoluble. But that won't happen in any of the cases that we will study. In all cases that we are going to study, it will dissolve in any of these solvents. And how to remember this? Basically, think of it like a scenario. There are three friends, H2O, HCl, and HNO3. They want to attack somebody. Now, I don't know the reason why, but they want to attack somebody, and that somebody is right in front of them. So, first, they send the weakest one, water. Water tries to attack this and fails. So next they send a dilute HCl, which again fails. So next they send a concentrated HCl, which again fails. And lastly they send nitric acid, which if it fails then it fails, and then the strong all of them go together and attack. Like this is the all of them together state. And if this fails, they just go away and don't disturb the salt anymore. So you can think of it like a scenario. This is not exactly a trick, but a different perspective to look at this. It's desperate and continuous attempts to try and prepare a solution which we can use for testing the salt. And after we have prepared the original solution, we are going to test for other groups. We will see this order later. Now first let's learn about the physical examination. What kind of inference can we make from the physical examinations? First of all, there is color test. If the soil contains an Fe3 plus ion, it will look green in color. A copper ion will be blue in color. A manganese ion will be light pink. A cobalt ion will be pink. And a nickel ion will be bright green. Now, how do I remember this? Well, this is a scenario. Imagine that there's a weird man. The man is pink in color and he also has a pink car. And wherever he goes, like if he goes to your house, the ceiling of your house will become green. Like it's some kind of special property this man has. If he goes to your school, the ceiling of your school will become green. And if he stands in the open daylight or open night light, then the sky will become green. And this is some kind of curse which is on the man. And this is a very fictional scenario. Don't try this at home. But basically the police, these are police guys, and they are very scared of this man, but they want to investigate this man. So what they are doing, they are spying on that man. This is a wall, and one of them is looking over the wall, and he is telling the clues to this guy over here, and he is making a graph of all the clues that they are seeing of this man. So this is the story. And how do I remember this? This is a order from this guy to this guy. Graph the clues of the pink man with a pink car on bright green night. Now, how do I use this to remember? Well, graph, graph, gr green, gr green, and graph ferric iron. So using graph, you remember that green means the ferric iron, and clue. Using clue, you say clue rhymes with blue, but instead of B you have put C. So graph the clues means that green Fe iron and blue Cu iron. Okay. And then of the pink man with the pink car on a bright green night. Okay. Now see, if you would have tried to remember this with like zero tricks, and you will have a difficult time remembering these five colors, or maybe you won't. But now that this image is in your mind, this image of the pink man with the pink car on a bright green night and two guys looking at him, this is a lot clearer to you now, and you will have a bit less trouble remembering this. And the reason you guys wanted to leave salt analysis is because of this remembrance, and that is what I'm trying to make easier for you guys. So now let's learn about the dry heating test. The NCRT only mentions these salts, and also they mention the Fe2 plus ion, but that is not in your syllabus. So the copper ion is white when you heat it. Like if you heat the dry sample of the salt, it changes color from blue to white. Similarly, zinc changes color from white to yellow, and cobalt changes color from pink to blue. Now, how do I remember this? Well, you are at home and you have a cook at home who is a boy, and then a guest comes who is called Zach. Zach is a common name in foreign countries, and you ask him, what can the small boy cook for you? Small boy in the sense not child labor. He is a he is small boy in the sense he is 18. Okay, so you ask Zach, what could the boy cook for you, Zach? Now, how do I use this to remember? Well, it's basically color then metal. What could white CU? What could the boy cook? Using boy, you have to remember blue, and using cook, you have to remember CO cobalt. What could the boy cook for you, Zach? Using you, have to remember yellow. Using Zach, you have to remember zinc. Okay. Now this was it for the physical examination. You can pause it right here and take notes. Then we can come to the dry tests. Now I am very sorry, but I was not able to come up with a trick for the group 1 ions. But I will tell you how to remember. And for others, I have prepared a trick. Well, first of all, let's learn how we perform the flame test. Basically, you have an instrument with a loop of platinum, the platinum loop, and you dip it in a paste of the dry salt. But how is it a paste if it's dry? Basically, we added concentrated hydrochloric acid to it, and it has become a paste. So we dip the platinum loop into this paste, and then we heat it in oxidizing flame. Like this is an oxidizing flame, and we heat it in it, and there is a special color of flame which is observed. Now looking at the color of this flame, we can infer what kind of cation is present in our salt. So if we, and this is specifically used for your group 1, but these are some extra colors you have to remember. So for group 1, if we go from top to bottom, well, there's also a trick to remember this. This is Lena K rubber socks. Okay, like lithium, sodium, potassium, rubidium, and using X, you have to remember cesium. Okay, but I was not able to come up with a trick for the colors. So unfortunately, you will have to brute force and memorize it. But it shouldn't be too hard. A way you can learn this is you already know the order from top to bottom of group 1 elements. Now just treat them like a order and remember them in order. How do you remember it? Just repeat in your mind: red, gold, violet, purple, and blue. Red, gold, violet, purple, blue. Red, gold, violet, purple, blue. Red, gold, violet, purple, blue. Okay, and I'm very sorry I was not able to come up with a trick for this, but I hope I can still help you in ways. Now for the others, what others you have to learn for the flame test? You have to learn calcium, copper, strontium, and barium, and the colors are very fancy names. Calcium burns brick red, copper burns blue green. And you know how blue green? Basically, the flame will be blue in color, but the core of the flame will be green in color, and it is really beautiful. And hence, I have also attached this YouTube video for you. Basically, use Google Lens to scan it, or if you're on a PC, just type it in. It's not too long, and it will lead you to a video where they are performing the flame test for various elements, and you can see it looks very beautiful. I really recommend going and checking it out because it will really amaze you. Like, it's really beautiful. Okay, So how do I remember the flame colors for the extra cations? Basically, Kaku sir is bald. This is a ordered trick, like this is used to remember an order. Kaku sir is bald. Like I'll explain you the story. This is a sir, okay, and he is called Kaku, and he has no hair. But how did he lose his hair? Basically, one day he met a genie, okay, and he asked, I want the ability to grow grass wherever I want, okay. So genie accepted his wish, but at one condition, that Kaku sir will have to go bald. So Kaku sir also accepted his terms and conditions, and he gained the power to grow grass wherever he wanted, anywhere, okay. So using this story, you remember Kaku sir is bald, bro is bald and creates grass. Basically, Kaku sir is bald, bro is bald and creates grass. Okay. So this was how you remember the flame tests. Now, this is going to trouble you a lot. Borax bead test. Okay. But this is a very theory heavy test, so let's learn about it. Basically, if you want to perform the borax bead test, first let's learn about the flame. What is a flame? Flame, the fire basically. I mean, no shit. But there are some special properties of the flame. If at a flame you look at the lower part of the flame, this is lower in temperature and the upper part is higher in temperature. And the center of the flame produces reducing character, while the outermost part of the flame is oxidizing in character. Okay. So this you have to remember. They have also asked this in JEE Mains as a PYQ. So please remember this and draw this in your notes, or I will provide you the notes today. So basically what you do, that you dip a loop of the platinum loop. Like in flame test we use the platinum loop. So here also you use this platinum loop and you heat it in a flame until it is red hot. Okay. Now while this is still hot, you will dip it in a pot of borax powder. Borax we studied in P block, it is Na2B4O7.10H2O. When you put that hot of a platinum rod in borax, this water of crystallization evaporates and you're basically just left with this guy coated on the platinum loop. So what you have to do, that now this is platinum loop, this is borax without the water of crystallization on it, and you heat it again in an oxidizing flame. No, not in an oxidizing flame. You just heat it again under this flame, and basically on the loop, this forms a bead, like a bead, a kind of lollipop. It forms, okay. And now you have your original salt which you wanted to test. So in that sample of salt, you dip this lollipop, this borax bead, and when you put it in the salt and then you heat it once again, and once you heat it in the oxidizing part and once you heat it in the reducing part, it is going to give you different results, and based on those results you are going to infer what kind of cation is present in your salt. Let's look at a bit of chemistry here. Basically, that borax thing, when it is heated, it forms boric anhydride. We studied this in P block also, and sodium metaborate. The BO2 minus is the metaborate ion. Okay, and the special property here is that if this boric anhydride reacts with metals, like I told you, if that lollipop is dipped in the salt, this lollipop has the boric anhydride, and when it reacts with the metal, it forms a metaborate. Basically, metal metaborate. And this is a general formula for the metal metaborate. And this is what is left on the lollipop for the final burning test. You have to burn it in oxidizing flame and then in reducing flame. Okay. So, yeah, I was not able to come up with a trick for this. Like, genuinely, you have to remember four colors for four ions. Basically, 16 colors you have to remember. And I was not able to come up with a trick for this. Well, a good news for you, you don't have to remember manganese. You can scrap this. But hey, it was easy to remember, and extra knowledge never hurts. And this will also illustrate an important concept to you, so I'll just teach you manganese. Basically, it is very easy to remember manganese and iron. Now, see, think of it like this: this is an oxidizing flame, this is a reducing flame. So, poor manganese, when you heated it in a reducing flame, it reduced its colors. Poor guy was light violet, happy, happy in oxidizing flame. But as soon as you put reducing flame, all the colors reduced to colorless. Poor man. You can't help but feel bad for manganese. And the same thing happened with nickel. Bro was happy, reddish brown violet, and as soon as you heated it in reducing flame, bro became grey. Bro lost all colors of life. You have to feel bad for nickel too, man, and manganese, the poor brothers. But well, copper was slightly sad. Why? Because it was blue and green, and one of those colors turned colorless, but still he has red left. So copper is somewhat okay, and iron showed an opposite effect. Bro was yellow, but he became more vibrant, became green. Like if you look at the color spectrum, I'll show you. You can see here that green is more towards the center, and you can see that yellow is kinda it's mid, but green is more vibrant and brighter. So it has an opposite effect on iron. One second, and it has opposite effect on iron. The yellow iron turned into green, but nickel and manganese, as we know, they became sadder, and copper became half sad. Now, this story might help you remember the inference of the borax bead test. You will have to brute force these colors into your mind, but at least I hope I made it somewhat easier for you. Well, that was it about the physical examination and the dry test. Now we will learn further. And also, this will be a long session. It will be longer than most of my previous sessions because originally, this session I was planning to do into three parts and maybe even four. But I decided to just say, nah, fuck it. I'll do it in one part only. Okay. What is this? Why did I write this? Oh, basically, this is like I tried to come up with something related to, in mathematics, you study the triple scalar product and it is how it is cyclic. So I tried to come up with something related to that. How? Basically, I tried ki this is BGR. Okay. And for the next ion, this red comes here like BGR, and for the next ion it becomes RBG, like this R comes here. How? Basically, red was here first, but for the next guy, red came at first position. And you know how blue and violet are somewhat similar colors? Blue came here, red came here, and GG, the G brothers, green and grey, they switched positions. But I thought this was very obnoxious and it wasn't helpful at all. But if it helps you, it helps you. I just told you. And for the it basically it does not apply to the next ions, but at least they have similar colors in both the cases. So yeah, enough yapping. Let's move on to the next topic, which is groups of cations. And I am very sorry, but you have to remember these groups because in the JEE 2022 they asked a direct question from which of these ions is not present in group 4. Okay. But luckily, it's easy to remember this because three of the groups have only one member. The group 0, as I told you, it is ammonium ion, and it is the only non-metal here. One second, I'll have water. Huh. Yeah, so group 1 has ammonium ion, but Group 0 has ammonium ion, group 1 has lead ion, and group 6 has Mg2 plus ion. These are very easy to remember. And for the second group, basically the white ones are out of syllabus. Okay. And the yellow ones we have to study the test. Now officially, cobalt is not in the syllabus. But in 2024 they asked a direct question. So I'm teaching you cobalt. Okay? Yeah, it's very pathetic they don't follow their own order. But yeah. Basically, now if you remember here I told you that you have to test for ammonia first, and this is why it is called the group 0, because before any of this begins you have to test for ammonia. Like, get done with the non-metals first and then move on to the metals. And how you test for ammonia we will learn, but what you do is first you test for ammonia and then you prepare your original solution. And when that original solution is prepared, you will first pass it through dilute HCl. If it gives that result, then it good. If not, you move on to the second step. If it produces a result, good. If not, move on to third step. Then again same philosophy applies. Move on to fourth step, move on to fifth step. Now, if the group 0 to 5 yield no result for you, then only you have to test for the magnesium ion, which is the group 6. Now, this is only two members, easy to remember. Only two members, easy to remember. But for the four-membered group, I made you a trick. Man, Zach cooks nice. Like, remember this story where we studied about the boy and the Zach? You had a slave. I mean, you had a cook with you, and there was this Zach guy who came. The boy said, "Nah, I will not cook for you. I am the, I am the one who will eat Zach's cooking." So Zach was forced to cook for the small boy. That's how you deal with child labor. But yeah, uh, and after eating the food, he said, "Man, Zach cooks nice. Man, Zach cooks nice." Okay. And for the fifth group, bad cars can't steer. Bad cars can't steer. Like, basically, you know how if there's a car and it's bad, then don't use it to steer. This is the steering wheel. It cannot steer and it is not practical or ideal in any way. Hence, these were the groups of cations, and you have to remember this. I'm sorry, but yeah. Now, what we have to do, we have to learn the individual tests of all of these cations. Okay, so yeah, let's begin with testing of the ammonium ion. So, how can we test for the group 0 or the ammonium ion? So, you will have your salt. Like, you are not using your original solution, you are using the salt, like actual salt in the crystal form. Now you have to add sodium hydroxide to it, and if it releases an ammonia smell, which means that ammonia is liberated. Like, imagine that this is your salt which contains the ammonium ion, and it reacts with NaOH and ammonia gas is liberated. You can see how that happens. Okay, so if this ammonia gas is liberated, and ammonia smell will come, of course. And if you remember, in cations we did a test when we were studying the chloride ion. The chloride ion had a preliminary test where the gas was HCl, and if you brought an ammonia rod close to it, it would give you dense white fumes. But here the exact opposite is happening. How? So yeah, here the same thing is happening, but instead the opposite way. You have the ammonia gas which is liberating, and you're using an HCl rod to create the NH4Cl, which is causing the dense white fumes. And this causes suspicion of the ammonium ion. Sorry. So when you pass the gas through Nessler's reagent, you have to remember this, the K2HgI4. When you pass the gas which has liberated from the solution through Nessler's reagent, it forms this weird precipitate. Now, For the Hindi speakers there, I'm very sorry for the non-Hindi speakers. You will have to remember this by brute force. But for the Hindi speakers there, I have created a trick which is hagu ya na hagu. For the non-Hindi speakers, hagu basically means going to the toilet. And number two, okay. So the person is sitting on a toilet contemplating whether he wants to go to number two or does not want to go to number two. So hagu or nahi hagu. See how it fits so perfectly. Nahi hagu. Okay. And you can answer that question. You can find out what his decision was by it was brown precipitate. Disgusting. But at least now that this disgusting image is in your mind, you will be able to remember the test of the group 0. And once this test has been done, if it passes, it passes. And if it doesn't, you now have to prepare the original solution using the steps we mentioned earlier. And then you will start testing for the next series of cations one by one. So, now let's learn about the test of the lead ion. And its reagent is dilute HCl, which means with its original solution you will add some dilute HCl. Now of course, if you have lead 2 plus in the original solution and you add dilute HCl to it, it will form lead chloride PbCl2. This Cl will take place of the empty valency of the 2 plus lead ion, and this will make a white lead chloride. Okay, now how do I make sure that, I mean, if you get the compound lead chloride, it there will not be written lead chloride on it. You have to test whether the Pb2 plus ion is present or not. So how do I test? Well, there are three ways of testing. First of all, you have to dissolve the precipitate in hot water, and the crucial step is dividing it into three parts. Okay, and believe it or not, if you have seen my first, second and third lecture, we have covered all of this earlier. How? Well, the first part is potassium iodide. Like, you are supposed to add potassium iodide to the first part of the division you made, divided into three parts. Potassium iodide to the first part. A yellow precipitate is obtained. Now, if you remember in the silver nitrate test, we learned that AgI is yellow and AgCl is white. The exact same thing applies here. PbCl2 is white and PbI2 is yellow. Okay. The second part, you have to add potassium chromate. How to add potassium chromate? I mean, you know how to add, but what is the inference? You will get a yellow precipitate and it will be soluble in NaOH. Where have we read this? Go back to the chloride ion test, and we had studied the chromyl chloride test, where we did the same thing. This PbCrO4, we got lead chromate from chromyl chloride with NaOH. Now this is very given that this is not a precipitate, it is soluble in NaOH. Okay. And lastly, the third part of the precipitate, we are going to react with dilute sulfuric acid. Now if there is PbCl2 and we react it with H2SO4, displacement reaction will take place and SO4 will come in place of the Cl2 and this will form lead sulfate. And lead sulfate is white in color and it is soluble in ammonium acetate. Okay, and where have we read PbSO4 before? We have read it when we were testing for barium. No, not barium, sorry. When we were testing for this sulfate. Remember, we got PbSO4 white PPT. So, all of these we have studied in one way or the other earlier. And some chemical aspects I need you to know about these lines, that lead chromate is insoluble in ammonium acetate but soluble in NaOH. Now you should know about the tendency of lead to form complex with coordination number 4. So if you add PbCrO4 with NaOH, it is going to take 4 hydroxide ions and make a complex with them. And 2 of these sodium ions will act as spectator ions and the other 2 will form Na2SO4 to stable, not Na2SO4, in this case Na2CrO4. because this ions gets left behind and this form the new complex. Two sodium take care of the spectator ions and the other two for combine with the CrO4. And similarly, here we study that the white precipitate formed with dilute sulfuric acid of lead is soluble in ammonium acetate. Like from here on, we will use AC for CH3COO minus, and we will use AMM for NH4 plus. Like as AC acetate, ammonia. Okay. So how is this soluble? Well, this is again a displacement reaction kind of. The the four coordination number complex is formed. What is the anion here? It is acetate. So lead will steal 4 acetate from here, and 2 of this ammonia is going to stabilize. Like in the stoichiometric reaction, the coefficients are 4. So 2 of these ammonium will stabilize the complex spectator ion, and 2 of them will take care of the sulfate ion and form ammonium sulfate. Okay, take a moment and note this down. We have done group 0 and group 1. Now let's move on to group 2. Oh, I forgot to tell you the memory aid. I care about such lonely people. Wow, a lot of you might resonate with this, but just know if you feel you're lonely, I am always here for you. I care about you, even if nobody doesn't. Okay? So, I care about such lonely people. Using I, you have to remember the first part has to be reacted with I minus or potassium iodide in spectator ion form. I care. Using care, you have to remember CrO4. And using SuCH, using Su, you have to remember sulfuric acid. Okay. So the first line takes care of the tests which are given to the three parts of the precipitate. One of them being I, one of them being care or the chromate, and one of them being such or the sulfuric acid. Now, why did I say lonely here? Because first of all, lonely has one, okay, and this is group 1, and there's also only one cation here, and it gets very lonely, okay. So this is lonely, and of course, people is for PB. I care about such lonely people, which means that using PB, you have to divide its precipitate in three parts. One of them reacts with I, one of them with care or chromate, or another one with such or sulfuric acid. Okay, this was the group first cation. Now let's learn about the group 2. This is one of the most difficult tests out of all the groups. So bear with me and I will try to make it easy for you. Now, we have to study specifically the lead ion and the copper ion. And the reagent here is H2S. Basically, if our group 0 test and group 1 test gave no result, we have our dilute HCl with the original salt solution. We are going to pass H2S through that. And this is going to be basically acidic H2S because acid exists from earlier tests, and we are going to add H2S, so it will become acidic H2S. And how do we add H2S? Basically, I'll show you the NCERT manual. This is we call Kipps apparatus. Okay, this is something you don't have to remember the diagram of, but they can ask you in MCQ how do we add H2S. So we add it using Kipps apparatus. Okay. Now, what do you think H2S will do? Here, HCl performed a displacement reaction and formed a salt with the cation. So here, H2S will do the same, and it will form a metal sulfide with the general formula MXSY. Like basically, maybe how can example of a sulfide, basically it can be Na2S maybe, or might even be MgS, NIS, CuS. This is just a general formula of a metal sulfide, and using this metal sulfide we are going to test for the presence of these cations. So I'll tell you a side reaction first. If nothing which is mentioned here is there and you still see a metal sulfide, so just know that if anything other than what is mentioned here is taken place, then the arsenic ion is confirmed. Like they can ask you in the MCQ. Arsenic is not in your syllabus, but still I added it, and hence I did not mention its tests here. And basically, it's when this precipitate forms MXSY, if it is yellow, if it's given to you that something reacts with dilute HCl and then with H2S with, or it says that say it reacts with acidic H2S and it forms a yellow precipitate, then you have to confirm the presence of the arsenic ion As3 plus. Okay. Now let's look at the normal case, in syllabus case, where the precipitate is black in color. If it is black in color, then it could be either the lead ion or the copper ion. Wait a second, didn't we just study the lead ion? Well, yeah, but lead ion is considered a part of both group 1 and both group 2. The only difference is that in group 1 it is precipitated as a chloride, but in group 2 it is precipitated as a sulfide. Okay, and this is the only exception, like this is the only ion which is in two groups, so don't worry much. Now the test is very cumbersome, and they asked a direct PYQ from this in 2024. Like the last shift had this question. Basically, if your PPT is black in color, you have to react it with nitric acid. And of course, this will form a metal nitrate like PbNO3 twice or Cu. Why did I square it? The 2 will be bottom. PbNO3 twice, CuNO3 twice. This is a metal nitrate. And you know that you are either testing for one of these. You can't test for both of these at once. You are testing that either Pb2 plus is present or Cu2 plus is present. So if you are testing for Pb2 plus, you have your metal nitrate here, and then you have to add S2SO4 if you are testing for Pb2 plus, and you know PbSO4 is white from the earlier test. And just so you know, once you have your metal nitrate, all of these tests of group 1 can work. Okay, and you have to remember this as a trivial fact. They can also ask this in MCQ, like if they are form question like you have a lead nitrate and then you react it with say you react it with potassium chromate and it is soluble in NaOH, tell me which cation is present. So you have to say lead, because the lead nitrate can go through the same reactions as lead chloride. Okay, now, this metal nitrate, if you know that you are going to test for the copper ion, then the first thing you have to do is you have to heat it. And when you heat it, this sulfide ion, it oxidizes itself into the sulfate ion. And consequently, it from copper sulfide, you form copper sulfate. And copper sulfate, as you know, we studied in the nitrite ion test. In the nitrate ion test, that solution turns blue due to formation of copper sulfate. So here also similar thing happens when CuS turns into CuSO4. What happens is that the solution turns blue because of CuSO4. Then you add ammonium hydroxide and the solution becomes even more blue. Like if it was say light blue earlier, it becomes darker blue. How? Well, basically this reacts with 4 moles of NH4OH, and NH4 it just basically it displaces the sulfate ion, and it forms a tetraamide copper complex. Okay, and this is deep blue in color. And oh, and this guy, potassium hexacyanoferrate. Potassium hexacyanoferrate, remember it with like tattoo it on your shoulder. We are going to meet this guy in almost every test we are going to perform from this point. Okay, and mains in 2025 they asked a direct question about what kind of tests the potassium hexacyanide gives. Okay, so once you react this with like copper tetraamide complex and it reacts it with potassium hexacyanoferrate, it forms basically the copper displaces the potassium, like it becomes the spectator ion, and it forms chocolate brown PPT. Okay, chocolate brown, like the color of chocolate, imagine it in your head. So that color PPT it is formed. And in most of the case tests of the potassium hexacyanide it will almost always, the metal you are testing it will replace the potassium, because potassium, as you know, it's very reactive metal. Okay, so that was it for the group 2. Now lead one you already know. I have made memory aid for copper one. Heating nuts made my coffee blue. What a weird case. Oh, it got more blue. Man, I will just eat chocolate. How do I use this to remember? Well, heating nuts. Heating the nitrate. Nitrate. Heat. Nut. Heat. Heating nut. Heating nitrate made my coffee blue. Heating the nitrate made my coffee blue. Coffee, you have to remember copper. And blue, you have to remember this oxidation which happens on heating your nut or the nitrate. Your coffee turned blue. And oh, oh, sorry, it turned even more blue. It got even more blue. Heating nut made my coffee blue, and oh, it got more blue. I will just eat chocolate. Like, of course, you will not want to drink a blue coffee. Ew. So you just said, man, for my caffeine overdose, I will just eat chocolate. Please, no coffee. I don't want blue coffee. Okay? So using this trick, you have to remember the group 2. Of course, this sounds silly and obnoxious, but now the image of a blue coffee is in your mind. And if you just take printout of the notes which I am going to provide today and you keep revising this, I don't think you are going to forget any of these tests. Like, this is just a aid. It is meant to help you memorize this entire test. Okay? So bear with me. And now let's move on to the group 3, which is aluminum 3 plus and Fe3 plus. Here I made the font size a bit smaller so I can handle all the tests in one slide and you don't get intimidated by multiple slides. So luckily enough, this is the third last slide of the lecture, and the reagent here is NH4OH plus NH4Cl. In fact, let's do some maths. Take NH4 common, Cl plus OH. No, please don't do this. But J is an objective exam, who cares? Okay, and even NEET. So you have this, how many minutes? 47. Man, this will take like 1 hour 20 minutes or something. Ah, okay. So you have Al3 plus Fe3 plus. You got your, say, group 2 failed. Okay, H2S did nothing. So to this H2S solution only, I mean, this original solution, it reacted with dilute HCl, gave nothing. So you reacted it with H2S, gave nothing. So that solution only you are now reacting with NH4OH and NH4Cl. Now, what happened here? That if you added both of these reagents to your result of the group 2, there are two cases which are possible. I mean, technically, there is a third case where the test fails, but let's say the test passes. So, on passing, there are two possible cases. One case is that brown PPT is formed. Now, if brown PPT is formed, you have to suspect the presence of the ferric ion, Fe3 plus ion. And to confirm it, you have to divide the precipitate into two parts. Now, get used to this dividing thing. In every test, we are going to divide precipitate into two parts to be sure, okay? So this was the precipitate which was brown in color. So we divided it into two parts. One of them reacts with K4FeCN6. The same guy we met here. Potassium hexacyanide of ferrite. And you see what I told you. The it replaces the potassium as the spectator ion. And it forms this complex, like this entire thing, you know, it has a charge of what was its charge, I forgot. No, whatever, its charge. And then this is balanced by four spectator ions, which is the four ferric ions which displace the potassium here. So, and this is a blue PPT. Okay, now I am sorry, but you have to remember the colors of the PPT. There is no trick to that, but maybe just reading again and again, it will help you remember the colors of the PPTs. Okay, and the second part of the PPT is going to be reacted with KSCN, potassium thiocyanate. Okay. And specifically this thiocyanate ion, like the cyanate ion is OCN minus, and if you replace O with S, you get thiocyanate. So if it reacts with potassium thiocyanate, blood red color is formed. And this is very easy to remember. Like the SCN, it just replaces the what replacement? It just reacts with the Fe3 plus. And this has negative charge, this has 3 positive, so 3 minus 1 is 2 positive. So FeSCN 2 positive. Blood red color is formed. And the first part, blue PBT is formed. Okay. So this was also a direct PYQ, remember it. And the memory aid for the brown PPT test is for Fe3 plus. The brown is fake. This brown color is fake. This brown color is fake. Using fake, you remember Fe. And brown color was fake. Put it in the pot. Pot means potassium. Put it in the potassium. Okay. And it forms this blue PPT. Scan it. It is red. Oh, I forgot to add one word here. The actual trick is that put it in the blue pot. Oh, what is that brush size? Put it in the... That is also big. Okay. Put it in the blue pot. Okay. And when you put it in the blue pot, you have to remember that blue pot. You have to link blue with potassium. And the brown was fake. Putting in the blue pot, it in potassium. That was the result of the first test. And scan it, it is red. Using scan, you have to remember SCN. And red, of course, you have to remember blood red. This is basically you found a brown substance. And you said, no, this brown is fake. I will put it in a blue pot. And then I am going to scan it. Okay. So this story is used to remember the Fe3 plus test. Now, if on adding the reagent, the PPT comes out to be white, you have to suspect the presence of the Al3 plus ion. And again, you have to divide the PPT into two parts. To the first part, you add sodium hydroxide and it forms a white gelatinous PPT. Gelatinous is like basically, jelly. Jelly you have seen. That is gelatinous substance. So white gelatinous PPT is formed, which is basically it is AlOH whole thrice. Okay. And this is soluble in NaOH and it forms NaLO2. NaAlO2 with AlOH. I don't think this is important, but I added because it was in the NCERT. So to the first part of the PPT, you add sodium hydroxide and the hydroxide ions, they displace the whatever was with the Al3 plus and they come in place of it. Okay. And this forms Al triple hydroxide ion, not ion, but Al trihydroxy whatever, aluminum hydroxide, and it is soluble in sodium hydroxide. And this is a white gelatinous PPT. Again, salt analysis is a dictionary. You have to remember this keyword gelatinous PPT. Then samajh jana, it is AlOH thrice. Okay. Now to the second part of the PPT, you have to send it under blue litmus. Why blue litmus? Basically, this has sort of acidic character. So when you put it under blue litmus, it will give you a red solution. And then you start adding ammonium hydroxide. So if this is like red solution and you start adding something which has an hydroxide ion, so this is a base basically, so this starts getting slowly it starts getting more blue. Okay. And if it starts getting more blue, you know that AlOH whole thrice has started forming. Like here it formed with NaOH and here it is forming with NH4OH. Now the white gelatinous property of it causes it to adsorb the blue part of the solution. Like what is adsorption? If you have a solid here and it has a tendency that whatever solvent it is kept in, it will pull the molecules of the liquid together and it will just form a thick layer of the solvent's composition on its edges. That is what we call adsorption. So here AlOH thrice does the same thing and it adsorbs the blue color from the solution. And in the end, when this process is completed after some time, you get a colorless solution in which there is a blue mass floating because it has absorbed all of the blue color of the solution. It is all gone thanks to the blue mass which is floating in colorless solution, and this we call the lake test for aluminium cation. Now the memory aid for this is you are in a boat. You have to connect lake with boat. Okay. And for the Hindi speakers, boat is called now. For the non-Hindi speakers, now is basically Hindi for boat. Okay. And using now, you remember NaOH. You are in boat. You connect both with lake and now with NaOH, and see that lake is made of jelly. Okay. Like jelly, you have to connect gelatinous. Lake, you have to remember lake test. Using NaO, you have to remember the NaOH which is used in the first test. Okay. I wasn't able to come up with something too creative about this. But yeah. And you know what? We can add one more word. You consider lake is made of white jelly. Like if there is a shallow body of water, it will appear white in color. So you jumped in it using a boat, but realize it is not water, it is white jelly. Okay. So this was the third group. Now let's move on to the fourth group, which is somewhat easier. Well, again, cobalt is your out of syllabus, but it asks the question, so I am teaching it. And here again, the third test failed. Okay, so now on this very solution, we are adding H2S. H2S again, what's the difference? Well, in group 2, it was acidic H2S because it was added on an acid. But near the end of the third group test, we added NH4OH to make the solution alkaline. And now solution has alkaline character. So hello again, I had to cut off recording abruptly in between because someone called me. So yeah, where were we? I was telling you the trick to remember that now is NaOH. I forgot. Where was I? I think I had explained this part, right? So yeah. So if this is your I remember now. Towards the end of the test, you are adding NH4OH, which made the solution more basic. And hence, now when you are passing H2S, this is H2S in alkaline medium. And JEE can ask you, or NEET can ask you, alkaline H2S. Okay. So this is test for zinc, cobalt, and nickel. If white PPT is there, always remember zinc salts are mostly white because of its full D10 shell. And if it's white PPT, then divide it into two parts. One of them, obviously, it reacts with potassium hexacyanide of ferrite and it forms a bluish white precipitate where zinc takes the place of potassium as the spectator ion, and the first part reacts with sodium hydroxide to form a complex. Like not exactly complex, it's just a basic salt. It's like ZnOH whole twice. Okay, zinc hydroxide, and it is soluble in NaOH by forming Na2ZnO2. Okay. And say the original PPT it was black. So this means it was either nickel sulfide or cobalt sulfide. Well, then remember that if this is the case, if black PPT is obtained in the group 4 test after adding alkaline H2S, then you have to add aqua regia. You can remember this by if there's alkaline H2S, then you neutralize the alkali by adding a shit ton of acid, which is 3:1 HCl is to and HNO3, which are both concentrated by the way. So 1 second, let me drink water. So aqua regia is used, and once you have put aqua regia, you divide it into two parts. One of them which reacts with dimethyl glyoxine, and it forms a brilliant red precipitate, or another keyword for this is rosy red precipitate. And the other one reacts with NH4OH, acetic acid, and potassium nitrite to form a yellow precipitate. Now, if the brilliant red precipitate is formed, then you confirm the presence of the nickel ion, and if yellow precipitate is formed, you confirm presence of the cobalt ion. Okay, so these were the tests for group 4, and here's the memory 8. Like, it is a nickel is a soldier and he just came back from war, and this is his general. No, this is not Hitler, but this is its general. And the general says that Nickel, you did a brilliant job. He tells him that you are a brilliant job, but Nickel is actually, he is very wounded, like lot of injuries. So the general says to him, but you are damaged. I know your ache, come to me. So of course, Nickel, brilliant, damage. Nickel, brilliant, damage. Even in games like PUBG and Free Fire, in short form, they call damage DMG, and that just happens to be the abbreviation of dimethyl glyoxide. So, Nickel did a brilliant job in the war, but he is damaged, injured. So, he says that I know your ache. I know your ache. Come to me. Okay. So this was the second line is a way of remembering the cobalt test, and the first line is a way of remembering the nickel test. Okay, so this was group 4, and lastly we move on to group 5. I wasn't able to come up with something for group 5, but it is rather easy, so bear with me. For group 5, after the alkaline H2S test has failed, you are going to add ammonium hydroxide and ammonium carbonate. Okay, and this is the test for barium ion or calcium ion. So you have your original solution. Oh, not your original. Why did I write original solution? Like, original solution after all this shenanigans have been done to it, all this test. If you react it with acetic acid, it forms something which you have to divide it into two parts. One of them you react with potassium chromate and it forms a yellow PPT, and the other one reacts with ammonium oxalate which forms a white PPT. Okay, so that was it for group 5. And basically, if yellow PPT is formed, you have to confirm presence of barium ion, and if white PPT is formed, you confirm presence of Ca2 plus ion. You can remember this using how the Ca2 plus calcium is present in our bones, and our bones are white in color. So calcium 2 plus is also white. And I wasn't able to form a trick for these. I am sorry. But I am sure that only this much you can remember by brute forcing it. And basically, once you have found the result of the first test, you perform flame test to confirm your result. What flame test? Like the one we studied here. For barium, the color was apple or grassy green, and for calcium, the color was brick red. Kakusar is bald, Bros bald, but he creates grass. Okay, so that was group 5. And lastly, if everything fails, group 0, 1, 2, 3, 4, 5, everything fails, you have to test for the last cation, which is the Mj2 plus, group 6. And I'll tell you the memory aid for group 6. My god, change your DP. Why is it white? So from DP you have to remember disodium hydrogen phosphate, and from my god you have to remember Mj, and from white you have to remember white PPT. Basically what happens, disodium hydrogen phosphate is this disodium hydrogen phosphate. You react your original solution with this guy, and the original solution has Mj2 plus. So all that happens is that Mj2 plus forms Mg ammonia, like Mg has +2, ammonia has +1, phosphate has -3, so overall charge neutrality is maintained, and this is white PPT. Okay, so that was it. That was entire salt analysis, and I am going to provide the PDF. So this has been a great journey. Thank you for watching, and I hope this helped you. We have covered entire cation part in one video, and that's it. Thank you.